welcome to the second episode of XTAC, Xebia Technology and Architecture podcast. I'm your host Shekhar Gulati, CTO of Xebia Global Services. Today we'll talk about DevOps ecosystem. So I have Mandeep Mehra with me. He's a DevOps and cloud expert working in industry for the last 2 decades. About DevOps ecosystem in general. We will not cover any specific topic today as per. We start with a general introduction about DevOps ecosystem. We want to understand where the ecosystem is today after its existence for the last 12 years. So as I remember, DevOps, I think dates back to 2008, 2009. So we will just try to understand how we see DevOps today. Once we have understood that, we will talk about the current state of DevOps ecosystem. We will try to understand if SRE is the next evolution of DevOps or not. Then we will talk about why digital transformation journeys which are using DevOps struggle. So what are the practices where most organizations struggle? And finally, we will end up with discussion on the what's new in the DevOps ecosystem. So we will cover progressive delivery and GitOps. Before we start, I just want to help you understand what Xebia is. So Xebia is a global IT service organization headquartered in Netherlands. We have offices in Netherlands, India, UK, UAE, and US. We help multiple customers in their digital transformation journeys across the world. We work on wide variety of technologies like Java, .NET ecosystem, Golang, JavaScript ecosystem, React, Angular, and mobile technologies like React Native, Flutter. And we also work with applications that are building new architecture styles like microservices, event-driven, serverless, along with monolithic as well. So we are an IT service organization doing all this work. So without further ado, let me start by asking my first question to Mandeep. Mandeep, you have been in industry for the last close to 20 years. So what's your journey in DevOps? So how you started and now how you see DevOps is evolving?
Sure, Shekhar. So I have been associated with DevOps before even the term was coined. So I was working for an organization. I was working as an integration architect there. So what the layout of the landscape of that program was, there were multiple teams, huge teams, and multiple vendors were involved. And I was tasked to perform a component integration, and then eventually, because of this large integration piece, so a lot of issues used to come because of integration. Now, how initially it was saying that everybody used to work in their own factories. We used to call them development factories, and they used to push code to the central organization where we were sitting. And a lot of time when the code used to run together, we faced a lot of issues, and we kind of analyzed why those issues are. Sometimes it was because the contract wasn't adhered to, it was reliability, people took a lot of assumptions that one component integration, how it interacts with other. Not enough testing was done on the individual side because they were working in individual silos. There was manual processes, a lot of times it was manual deployment, manual change of configuration, and somebody did a change on their environment and forgot to communicate that. So all of those issues used to collectively come into an integration environment.
Okay, Mandeep, just one question here. So how was your team structure at that point of time? So did you had some kind of a release or a build team, or it was all IT people there? So what was the team structure?
So originally it was kind of decentralized. Everybody has their own individual teams on their individual dev side. And there was one team which was collectively integrating all the things together. But the automation was lacking. So there was a common central team which used to call an integration and deploy support team. But enough tooling wasn't there. They were manually relying on the release notes or the documents given by the individual teams. And then they used to push code into integration environments and just hand over those release notes to production operations guys to put stuff into production. So all manual handover was done from one team. Okay, so coming back to the problem, because it was so vast systems and everybody was following manual processes, no consistency in the whole organization. So a lot of time what happened when the code was given for testing, the testing team struggled with basic issues, infrastructure issues, systems are not running. If one application is running, the other application is not running, and they used to do all kind of a blame games that it's problem because of infrastructure or it's because of code, it's because of configuration. So that's how we started into this, looking into the problem and said, okay, now since the scale is huge, we definitely need an automation that can solve a lot of problems here. So we organized a team. We didn't used to call our DevOps. We were just integration and deploy support team. And the team composition was, we had introduced a platform architect there. Deployment and release engineers were there anyhow. So they were there part of this team. And the other thing we did different was we introduced an engineers who had a background of coding. Because a lot of times we had to do an RCA, that whether that issue is coming from a code or a platform, we need somebody who has the knowledge of code, don't know the whole software functionally, but they have first-hand knowledge, how the things work, what protocols they follow, what are their connection parameters, how they talk with other services. So we took those engineers also as part of our team.
Okay.
Okay, and then we started standardize everything stuff. First of all, we enforced CI practices because everybody was building on their own way. So we enforced certain CI rules, took advantage of tools like Jenkins, so that everybody follows the same pipeline, how to build the code, how to enforce the standards on unit testing, static code analysis, and a central dashboard was created where everybody, we have a view of all those findings, all the tests that have been run into the individual development factories. In fact, we did it to a level that code, database scripts, external properties files, everything was version controlled and given as a part of run as a part of a CI pipeline. So generally,
just one question here, Mandeep. So how long it took for you to make sure that all the teams in your organization were following that? So how did that happen?
Okay, so we didn't took a big bang approach. We started with one team to test out. And we established the principles. We gave them all the scripts, all the pipelines, how it should work. And then once it was successful and the initial issues were ironed out, we started scaling team by team. And there were a lot of teams involved. There were around 50 plus teams. So it took almost more than a year to get that standardized across the whole enterprise.
Okay.
So initial wins and the plus support from management was good to get those things implemented.
Okay. Okay.
Now, so continuously, I mean, on further describing how we achieved that was, so that is one on the CI side. We standardized and enforced all those rules. We introduced a CI for database. So we have a sandbox where database scripts would run and we see normal database scripts and the rollback also work correctly. Apart from that, what we did was next we attacked the platform. Now, because everybody had their own version of platform, they used to do changes on their own manually. So we said, okay, we should stop doing this and rather follow a engineering approach where everything will be done by a code. So we standardized platform creation script that was shared across all environments, dev environments, QA, integration, post-production, and even production environment.
So at that time, did you use some configuration management tool like Puppet, Chef, or you went with just shell script or probably PowerShell script?
At that time, the tools weren't that popular in the industry. There was Chef was there, Puppet was there at a later stages. So when we began, there wasn't. We started with the shell scripting and we were using WebLogic platforms. So a lot of stuff from WebLogic's WLST, online and offline scripts were used. So partly Puppet was there and partly shell scripts were there at that time. Okay. But we had to do a lot of effort to get a robust shell script because shell scripts are not designed to cater to this workload. So we have to, a lot of principles that we see these days that these configuration management tools follow, we have to do it by hand, like idempotent, robust error handling. So all those stuffs were done manually at that time or handled in the script.
Okay.
So once platform was ironed out, so then we targeted the deployment part. So we know that now the platform issues wade away because we had consistency in the platform. So next we attacked the deployment. Automated the deployment part, and then also we introduced something called as a post-deployment verification suites at that time, so that when a deployment engineer does a deployment, he can also verify the application is running fine, the platform is stable before handing over to the next team to use the application. So we involved developer guys to create post-deployment verification suites. They were typically run through SOAP UI or curl commands so that we see the applications is running and it hits every tier of an application, not just web, middleware, database, or external system. So we get a clear view, things are running fine.
Okay.
Yeah. So other thing also we introduced later on as we move on, we started getting into problems that sometimes the design of application changes or the way they're doing things change. So we had, and we just get a surprise. Okay, now there's a new infrastructure requirement or new way of working. An application has to use that. So we started having our representatives from different teams participate in those architecture discussions of the developer team. So we introduced in the Scrum meetings that not daily, but whenever a critical decision has to be made, somebody, a representative from this integration and deploy support team will be part of there. and they can give their views on, okay, how things are done or what you have to do in case you make your system reliable and stable. Because
was this project following agile? Just for my, was this project following agile development model at that point or not?
Yes, it was agile. It was Scrum-based, that model that we were using. Yes.
Okay. Go ahead.
So collectively, if you see, the whole story was introducing CI, introducing automated deployment, platform creation, scripted, standard way, team composing of skills so that do can RCA, because that was a critical part. One of the key aspects of this team, or the advantage of this team, was that these guys knew platform, these guys knew code. So they could quickly identify what is going wrong and directly pinpoint, okay, where the problem lies, rather than sending it back to development teams and they're struggling where the issue is, because it was all cross, multiple teams are involved, and we don't want to have that blame game going on in the system.
Okay, got it. Just for my understanding, so what was the time frame of this journey? So I am assuming that you did the development, then you realized you were facing some issues, then you went with this. So what was the time frame in which you were able to achieve all of this?
So like I said earlier, when we started this and we were achieved at a certain stable condition, it took around 12 to 16 months as a whole. But initially, it took time, 1 or 2 months to do the development, do setup stuff. And between 3 to 4 months, we were in the first project to implement these practices.
Okay, got it, got it. Fine. So the multiple practices that you applied, so which practice in your view gave you the most value? So because what I understand is a lot of organizations start with the development effort, they take that very seriously, but they don't take automation testing very seriously. So in your experience so far, so which practices out of these give the most value? Or if you have any opinion on that?
Yeah, so see, like I said, the problem really lies in all these areas, but if I have to weight which practice gave more value, was on the platform automation. That was one part. A lot of focus on the test automation part also, because we try to automate or integrate those test automation frameworks into our pipeline. So that gave a really confidence, okay, things are working fine, and even we got a confidence that, okay, whatever development teams are doing fine is good enough for an application to be stable enough.
Okay, got it, got it. So Mandeep, one question that I have is, like, DevOps is in, so people are talking about DevOps, I think, for the last 10 to 12 years. So the first time this term was coined, I think, is way back in 2008. So how do you see this term value or the meaning of DevOps has changed over the last 10, 12 years? So where do you see DevOps going now, or where it is?
Okay, so just an interesting thing. I mean, when we were working on this way of engineering, we didn't even call it as a DevOps. Somebody said, okay, it's a new term coined. Why don't you call yourself as a DevOps team? So, okay, we did it. So, but when we saw initially, DevOps was very loosely coupled term. Exactly. So when it began earlier, it was a loosely term where good practices were kind of collated together, but there wasn't any concrete way of doing how DevOps should work. But eventually, with the time, now we have very focused terms for particular way of working. For example, infrastructure as a code, and GitOps we will discuss maybe. So GitOps is another term coming up for that, or progressive delivery, which is really focusing on your continuous delivery much. These practices or terms weren't coined at that time, and they were kind of applicable. So everybody had their own view of implementing DevOps or attacking. Somebody used to call, okay, if I'm doing automation, for example, I'm using Puppet Chef, I become a DevOps. Or somebody, I'm using just continuous integration, I'm becoming DevOps. But now the things have stabilized. We have more concrete terms focusing on an area to address the problem in hand.
Okay, okay. So do you believe in the concept of DevOps team? Like a lot of organizations, I think you might have also seen that they have a team now, centralized team called DevOps teams. What's your opinion on that?
Yeah, that I would say is more about how you want to arrange, because see, DevOps doesn't have a standard definition and way of working. So everybody in every organization you go, they have one way or another way of implementing DevOps. Some try to hire like DevOps engineers, so-called DevOps engineers or automation engineers as part of their development team, which do the operations part, like managing CI, managing releases, that part. Larger organizations I've seen, what they do is they tend to create a core team so that they can create a base framework, and they then become a change agents from their team, which become as a shared services across different development teams to get those practices and principles implemented.
I think that is also more aligned with SRE approach as well, because then also you have a centralized team, then you give people to other teams.
Exactly.
Do you think that? Yeah.
Yeah. So SRE has been, I mean, it's one of very concrete way of DevOps because it clearly defines what SRE would do and how you should practice and what are the principles involved in SRE. So that's why, which is more focused on the ops side of it. So SRE is on stabilizing the platform more. But DevOps in general is still a loosely coupled term, but now that few standard terms are coming up, GitOps, progressive delivery, infrastructure as a code. So that gives a focused and narrowed approach on how to implement those principles.
Okay. So which DevOps practices, in your opinion, most DevOps engineers should follow? I understand there are many. So which do you think DevOps engineers should follow?
Okay, so I'll just give you quickly how at Xebia we work around DevOps or how we organize it. So we have our famous train model where we show how DevOps should be landscape and the fundamental pillar being the agile software delivery processes, followed by adoption of CI practices, continuous integration practices, continuous delivery, continuous deployment, infrastructure automation, and then continuous monitoring once the things are in production, so that you have a view of your applications running back to the development team. So it encompasses the whole value software to end users. I mean, whole gambit of delivering those values and software to end users, ensuring the quality. Okay. Now, the areas of influence, or you can say the practices that a DevOps engineer should follow. Typically, we at Xebia follows 5 ways principle, which starts with automated build. Which when I say build, it's not just building, but it's checkout, compilation, unit testing, static code analysis. Even now, DevSecOps is catching up. So introducing your security scan, app scan as a part of your pipeline, because it's a fundamental best practice of doing a left shift approach. So keeping that in mind. So the sooner you do these activities or find out the bugs, the less is the cost of change. So that's the first part. The other part is, like I said, automated deployment. When I say deployment, it's not just about putting up your code, your binaries, your database scripts, your configuration, your policies, anything which your application requires to run from an application perspective, not from platform at that per se. Okay. Of course, when you transition, you start with binaries first of all. Eventually, you move into configuration, and then lastly, you attack database. The third important activity or focus area is the automated testing, be it functional, performance, security, UI. So again, left shift approach, do it within your sprint, have your artifacts ready to be deployed into production with all those testings done. The next one I would say is the automated provisioning part. So this is where provisioning your compute, network, storage, and if you are working on a traditional data center, generally compute, network, storage is not a day-to-day job. It's one time done statically, but the majority of the part is the configuration management, changing any platform runtimes, changing any operating system parameters. So automate that part, take help of different tools and achieve that. And the last but not least is focusing on the architecture part, because unless the application architecture is not able to facilitate these practices, it's really hard to implement those.
Got it. So what is not DevOps in your opinion? So we talked about what DevOps is in a loosely form, but what is not DevOps?
Yeah, so see, this is very important. Like, it's a very good question because a lot of time people say, okay, what is DevOps? They have their own perspective, but they really don't understand. It's not just about automation. It's not just about a culture change, or it's not about the way engineering practices are being followed. It's a collection of all things. So like I said, if generally there is a term called as NoOps, that is typically coined by the operations guys, where they feel that developers will now do the operation work. And the fear is that, of course, if developers are doing their operational work, their jobs will be taken away. But that's practically not the case. It doesn't mean that you don't need operations. It's being done by developers. It's about upscaling the operations or changing the mindset they have been handling the releases or they have been handling the applications. Now, especially with agile software methodology, where releases come very often, the traditional way of coping with releases is not able to come up to the speed the way development team wants. So that's why our adoption of these new practices and tools and automation really is the thing which operations guys should adopt. The other thing I've seen typically with DevOps is that just if I've put a certain kind of a tool, like I was saying earlier, if I put a tool like a Chef or Puppet or a CI tool like a Jenkins, I'm using DevOps, but it's not just about those tools. It's about the whole gambit of whole landscape of software delivery. So just a tool will help you automate or attack a certain area, but it won't be an end-to-end scenario.
Yes, I agree.
Yeah. And the other thing is my personal opinion is that there shouldn't be any title like DevOps engineer. That's my personal opinion, but I've seen, I mean, everybody in the field, IT industry say, okay, we need a DevOps engineer. So
True.
DevOps can be a company, can be a DevOps, but an engineer can't be a DevOps. He can be an automation engineer, a test automation engineer, or a platform engineer, or a network admin, or a database administrator. But that title itself is a misnomer here.
Yeah, I think it's a set of practices that help you deliver value faster to the customer, and that's what I see it as that. And then you have to incorporate both the tools, people, product, and all those things come together. Okay. Yeah. And what do you think? So do you think Agile is a prerequisite to DevOps? What's your opinion on that? A lot of people say that. I just want to understand from you, how do you see?
Yeah, I do see, because see, fundamentally, if Agile wasn't there, there won't be any emphasis on DevOps practices. Because you won't be releasing software too often, there won't be too often changes done. So Agile is kind of fundamental to DevOps, and by definition is earlier, even before the DevOps terms was coined, it was typically referred to as a phrase like extending your agility to operations. So it's really about that.
Yeah, that's a good term. So Mandeep, just moving on to the next thing now. So you have been involved in multiple digital transformation initiatives in last many years. So where do you see most organizations struggles? Because as per my understanding, a lot of these initiatives still fail, or they don't deliver value that the customer expects. So where do you think that people struggle with DevOps in these whole journeys? And if you can start with probably how you go about doing these journeys to start off, and then talking about where people struggle.
Okay, so I'll just quickly walk through our methodology typically that we use, and specifically at Xebia, how we typically go for digital transformation or onboarding an organization onto DevOps journey. So fundamental is the agile software practices. So that is what we enforce even before thinking about DevOps. And typically when we start an engagement, we start with some kind of a maturity assessment, so that we know what practices currently an organization is follow. That's quite a logical approach also, that what practices they have been doing, how mature they are. So we go and do a maturity assessment. We select a couple of projects in the organization, and we kind of interview everybody, right from the guy who gives the requirements, your product owners, your development teams, test leads, release engineers, deployment engineers, operations guys, infrastructure provisioning guys, support guys, and knock center guys. So we get their view, what the pain areas are, what their process is, so that we have fair understanding of the landscape. So once done, we kind of build a roadmap on top of that based on our assessment. And what we try to rate on different practices, like I discussed about 5 ways earlier, we try to rate them. We have our own proprietary framework. We try to rate them on which level they are in adopting those practices. So organizations which are very new fall on level 0, which is more of an ad hoc way of adopting practices. But some organizations have adopted practices in CI, but they are lacking in other areas, or they have adopted infrastructure as a code or automated provisioning, but lack in other areas. So we come up with a roadmap defining all in terms of people, process, and technology. That is presented to the management and agreed upon. One other thing important here is in the roadmap is to measure it, because now we are on a transformation journey, and now if you want to implement this roadmap, we should have a right set of KPIs to follow. What are the metrics against which we are measuring it? Because if you can't measure it, you can't manage it. So this is again one of the biggest drawback where companies fail, because they try to go with what is the flow, implement DevOps or implement tools, but they don't really measure the value they are getting out of it. So once this roadmap is there, of course, we go and then do implementation part of it, where our consultants go, they do on hand, which we call active coaching if it's needed, or they do actual tasks. They work with different development teams. And while doing, we also go and select champions among their teams, because we want them to become the change agent further down. When our consultancy is finished, they can move, expand or scale out these processes across the organization.
Okay.
So, yeah, and like I said, so KPIs are an important part here. We do a lot of dashboarding. We use a lot of tools to facilitate us in creating those dashboards and measure those KPIs. And once we have established to a certain level, agreed upon level, we come up with some kind of a sustainability model where the knowledge transition is given to those champions. We make sure that when our consultants move out, the organization is able to carry forward those initiatives successfully across the organization. So this is how we typically work. But what I've seen is, coming to your question, where organizations struggle is. So in these typical engagements, typically after we move out, this is the point where they lose the motive or they lose the energy. So that's one area of failure, that they should to continue the practice. Now we've tried to identify why these things happen. So one of the fundamental failures of these practices or DevOps adoption is that a lot of times I've seen in organization, the initial motive comes from the bottom team, like the development team. They want to adopt these practices. Now, if they start and there is no management buy-in into that, so it is bound to fail at a certain point. They can go up to certain levels, then of course the whole energy spent or the efforts taken will go in waste. So this is fundamental, that this should be a top-down approach rather than a bottom-up approach. So this is where organizations struggle. Now, if there is a management buy-in, the other areas I typically seen is across the scaling of these practices. So people start, or organizations start with adopting practices focused on a particular project, but then they struggle how to scale it. Okay, because each project have different challenges. They try to fit the same model everywhere, which doesn't work. So you have to have some core practices defined, but then adapt from one project to another, because each technology behaves in a different way. True. So that's another area I've seen organizations failing in adoption, or they haven't reached to a level where they should have. Another common area of struggle is seen with the ITSM practices. Now, like history, we know ITSM has been there to have very restricted way of putting stuff into production, because you need a controlled way. A lot of auditing and backtracking is needed. Whereas if you look at the DevOps, which talks about continuous delivery, every 2 weeks you have to put stuff into production. And if you go into this change management process or follow ITL processes, things slow down. So there is a conflict. A lot of organizations I've seen, they try to automate their release engineering, but then the ITSM becomes a big ball or hindrance to them.
Yes.
So these are typical challenges from my side.
And how do you see, like, is there, in your experience, do you see that companies have formed some kind of a enterprise level governance model that they try to use, something like that? Or is there anything mature in the industry right now that people do for large organizations?
Very few organizations have seen, they have become mature. They have been long into the journey of DevOps, so they have learned from their mistakes and kind of formed a governance around having a core central team, DevOps, who looks after the all cross teams implementation. So they have adopted or hired DevOps architects, which works across team, and then DevOps engineers, which are working on the ground, embedded within their individual development teams.
Yeah. One more, I think you talked about the buy-in from the management, but how do you see that? Because a lot of people, when they talk about DevOps, they also focus a lot on the culture aspect. So people say tools are easy, culture is difficult. So in your experience, organizations which have done well, is it about the culture or the management, then about the tools? So what's your opinion there?
Okay. So see, they both go hand in hand. It's not just if you change the culture, things will work, or if you just introduce tools, it will work. So I'll give you an example of an organization which was very vertical in nature. There were vertical groups, and they used to report to their representative heads. For example, developers used to report to their development managers, testing guys used to report to their test managers, and of course, operations team used to operations manager. Tools were introduced. We had all kind of tools you name in the industry were there, but still there was a lot of friction among dev versus testing versus operations guys, because they were kind of vertically organized and not a horizontally organization. So culture alone will not do, or technology alone would do. So now from a culture aspect, the change in mindset that, okay, for example, I was talking about ITSM, these guys or the change control board should know, if I'm doing a change and I've been doing those changes in small amount, it doesn't introduce the same amount of risk into my production environment as a big change would do. So if I'm coming from a mindset of a traditional application where I would wait for 3 months or 4 months to do a release, so the amount of change that will go into production, the risk is high as compared to if I'm doing an incremental changes like an agile. So that mindset change is very hard to do, and that takes time.
Okay, got it, got it. So lately we are hearing a lot about SRE. We covered that. I think we started having brief discussion about it, I think a few minutes back. But where do you see SRE now? Is SRE the next version of DevOps? I think you talked about SRE is a more prescribed way to do DevOps. So how do you see SRE being adopted in organizations, and should people only care about SRE now?
Okay. So I'll just talk about brief history about SRE, how SRE came into picture. Now, the SRE is term found by Google. So this is how Google handles its infrastructure internally or their applications and operations. Now, when the world was talking about DevOps, Google was internally doing these SRE practices. So a lot of things that by overlap, and hence the confusion in the market that what is DevOps, what is SRE, are they same terms or similar, or is it next form, like you said. So most of the practices, if you see, they overlap. But what SRE does is has very concretely focused and specified what are the practices and principles to follow, whereas DevOps has kept it loose end. So like it's rightly said by Google itself that SRE is like a class which implements DevOps interface.
Yeah, I like that actually. Yeah.
So they define a concrete way of implementing SRE. So DevOps is one concrete way of SRE. It's not just like a different way of doing stuff, but a prescribed way of doing things.
Okay.
Now, yeah. So if I go further, so what SRE, how it differs, if I have to fire a DevOps engineer or an SRE engineer, so what you need to focus on really is somebody who applies engineering practices to the mindset of operations or doing operations. Now, operations guys have a typical mindset of doing things in a manual way that, okay, an instruction will be given by the dev team, I'll follow that document and I'll implement it into the environment I'm handling. And they don't follow engineering practices or the way development engineers or software engineers work. So SRE typically combines these two mindsets. So it's like a operations guy who has a development background is handling operations. Now, why I say, or why even SRE emphasizes a development background is that because he'll try to look from a problem from a development or software engineer perspective and try to solve it that way also. For example, if I'm doing some stuff or modifying certain kind of a configuration on a system manual way, a software engineer would say, why not write a program and do it in a very quick way so that I don't struggle doing manual stuff or monotonous stuff daily. Okay, so this is typically termed as toil in terms of SRE, that okay, you try to reduce toil and try to take away the stuff which is of low value or which will take a lot of time and try to automate that. Okay. So the mindset which an SRE engineer will be very different than a traditional operations guy. For example, I've seen in SRE, like I give you an example of my case also. Earlier, we were having a traditional team, and so developer used to say, okay, go and increase the heap size or go and spin up another server for my application. Now, when we introduced that platform architect and those engineers, they started questioning, why do you need an additional server? Why not this heap memory is enough for you? How often you are doing garbage collection or what garbage collection policy you are using in your code? Why your code is having so much memory, whereas other applications are running on just normal 2 GB heap size? So they start asking these fundamental questions and find out the root of the problem. Because the very nature, they have a development background, so they look from different angle altogether. So they ask these questions and then they say, okay, if you need a additional server, why don't your application is elastic enough so that if needed, we can spin up dynamically and give you a solution. So you don't have an upfront cost of running 4 servers together, just start with 2, and if your load increases, we'll increase it. So they attack these problems from a programming perspective. So that's the real advantage SRE gives into the picture.
Okay, got it. Yeah. So now, in your experience so far, so what are you seeing is the next steps in the DevOps ecosystem now? So where DevOps ecosystem is going?
So in DevOps, like SRE is one we have been seeing in the market, a lot of SRE demand for SRE engineers now, because that's they focus on making a platform stable and plus supporting applications also. For example, you have an SRE engineer for a Kafka platform, SRE engineer for a Cassandra or a database platform. So they have a very focused approach because now with all that digitalization of the applications, we have stuff moving into production, and now it's the era of stabilizing those environments. So that's one thing.
Just one question on that, Mandeep. So how do you see platform teams, tooling teams, and SRE will work? Are we saying that SRE team will be will be the guys who will be owning the platform and the tooling team, or how do you see that? Because I also hear these terms like platform team, tooling team. Now we are saying SRE team as well. So how they all will work together?
Okay, so just a brief now, even see, SRE team is not like it's a new skill. My network engineer company is an SRE who manages my network. Okay, a database operations database guy is an SRE who manages a database platform. So in a lot of organizations, they have been rebranded to SRE engineers, and their scope of work has increased, or they have adopted SRE practices also in doing that. So if we talk about platform engineers, they have adopted tooling of doing stuff automated, like using Puppet, Chef, or Sort in that matter, and have moved their skill from manual to automated. And they started encompassing these SRE principles as they do their regular day-to-day work.
Okay. Okay. Yeah, you're saying the second thing in DevOps ecosystem. Yeah. So what's the second thing that people should look for?
So now that I was saying DevOps has been loosely coupled. So now there are a lot of new terms have been coined, and they are very focused. And the good thing is that when you have a focused terms, you go by the boundary of this terminology and try to introduce those practices. For example, GitOps is one thing, which if you see fundamentally is nothing but doing your infrastructure code in a right manner. For example, now if I'm automating an infrastructure, I'm writing code. Now, if I'm writing a code, it should be version controlled, very obvious for a software engineer, but not so obvious for an operations guy. Okay, so I should use some kind of a versioning tool. Specifically, GitOps says, since it's Git, it says use Git for that. Okay, now if I'm writing code, I'm doing a check-in. Before check-in, I should get it reviewed by somebody. So that's a normal software engineering practices. So start adopting those practices in your infrastructure code also. Get it reviewed, and if it's reviewed and all things are done, kick off your pipeline. It should not be a CI pipeline, but a pipeline so that you can automate even the implementation or running that code. So these terminologies, you know in a very clear, crisp manner that if I have to adopt a GitOps way of working, what should I do? I need a Git source code repo. I need somebody to do a code review, and then I need to establish a pipeline so that code can be now deployed. When I say deployed, it really means it can go and create infrastructure. It can go and create modifications in the infrastructure.
Mandeep, in this, one thing that I always miss is what about the configuration properties or the values or the secrets? So where do they go? So they are also part of your Git version control, or you will use something like Vault or something different? How does people do that?
See, definitely sensitive values nobody would like to put into Git. Okay. Unless they are encrypted. So what I've seen both implementations, they use encryption, but the encryption key itself sits outside the code. That is done typically in a tools like HashiCorp Vault or in cloud-based vaults. It can go recovery vault or a service vault. They can go there. But yeah, along with code, some configuration values go along with the code. That should be version controlled also. In one of the implementation, what I did was your code, your configuration that goes along with your code and your database. All three are version controlled, so that tomorrow if things break because there was a change in your configuration property, you know, and you can track back.
Got it. So are organizations adopting GitOps? So where it is? So it's being adopted right now?
It hasn't been adopted like in a true sense of GitOps. People are doing infrastructure as a code, but they are not following the other processes like, okay, how to trigger those. Some ad hoc implementation I've seen, but I see a huge capacity to adopt GitOps. There's huge capacity available there. Yeah. And in fact,
sorry, go ahead.
Just to add to that, this can be even what we call a new term coming up, cloud native CI/CD. So which can be adopted to platforms like Kubernetes, where configuration is typically stored in Git. You do merge request, review it, and then you implement it. So that implementation could be creating your pods, services, persistent volumes, network policies, config maps, all those stuff. So same principles can be even applied to delivery of applications onto Kubernetes platform.
Okay, got it. And I think any other thing that you're seeing DevOps ecosystem is adopting or will be adopting in the near future?
Sure. So one other thing I've seen since now adoption has matured in the sense that people have no CI practices now. They have been doing platform automation. What's lacking has been on the release side, how to do continuous delivery part of it. So the term progressive delivery is picking up now these days, which is more focused about how a continuous delivery should happen. Now, again, as a loosely coupled term from DevOps, continuous delivery should happen, but how exactly it should happen, but that's what progressive delivery defines. where the use of feature flags can have support you. That okay, certain feature you want to deploy, but you want to give it to a certain audience, or rather going by a progressive delivery terminology, that it is only open for developers to begin with. So what it gives a big advantage that developers can now test their code in actual production, not in just QA environment.
So the testing in production kind of a thing.
Yes. So once it's open from a dev perspective, now the ownership can go of that feature to a limited audience where they can do an A/B testing, where a limited audience can go and see that feature, how it works. And eventually when they are happy, they don't report bugs or it's stabilized, you put it for the whole end user so they can use it. So terms like feature flags helps you controlling what features you want to turn on and off so that you can test it on demand or remove it if you find an issue with that. Doing a canary release so that certain audience can go and test that feature before rolling out to the full audience.
Got it. Got it. So how it is different from continuous delivery and continuous deployment? So I think these were the two terms that from the start we have been hearing in the DevOps. So are you saying that progressive delivery is more again prescribed form of continuous delivery?
Continuous delivery, yes. So see, continuous. So I'll answer your first question on continuous delivery and deployment. Now, I haven't seen companies yet maturing onto continuous deployment, which it's like if you have your code tested out, it's ready for now deployment onto production, and it's no more an IT decision, it's a business decision. So this is what continuous deployment is. So I'm able to deploy onto production on demand, or if I'm following a policy-based approach and I say during my testing no bugs found, it's good to go into production. Now, it's easier said than done because continuous deployment means you're going to deploy into production. There could be an outage. You need a rollback. So you have to be very strong on how your features are released. If needed, you need to be rollbacking it in an automated fashion. So that's what continuous deployment is. It really needs a really matured thinking, really matured softwares so that you can achieve continuous deployment.
Okay.
Now, coming to progressive delivery, how it's different is that in progressive delivery, we are not delivering to the full audience when you do a deployment. You giving it to a limited audience and you change the ownership of that audience also, right? To begin with, it's dev. Then you say it's your limited testing team maybe. Then you say, okay, it's now your actual users, but limit audience, and then 100% of audience.
Okay. Got it. So that's what basically A/B testing and canary releases came. Yeah.
Yes. So tools like we have implemented one tool launched darkly also that really helps in feature flagging. That's a very good tool in terms of web application and mobile. So you can control features, turn on and off externally without redeploying and see how your features are behaving here.
Okay, got it. Good. So Mandeep, just to end this discussion, so I think we had a great discussion today. Just to end this discussion, what's your advice to the young engineers getting into the DevOps ecosystem? So where do you see how they should go about in this field?
See, personally, also when I interview guys, what I try to look for them is have they done some programming or not? Because unless you know programming or you're from a programming background, it's very hard to justify the job of a DevOps engineer. So this is one thing that they should adopt some programming, either be a JavaScript based Node or Java or C# full programming languages, but definitely they should do so that they understand the full SDLC of it. Okay. Now, apart from programming, since they have to look into operations side of it, the next thing I see is very critical for them to understand the operating system they are working on. So they should be a good operating system administrators. They don't need to be a full-time, but they need to know what it takes to configure an operating system like Linux or Windows for that matter. Also is from operations side, it's important to understand networking because now when things are very dynamic and cloud is coming into the picture, so everybody it's like a software defined network. So networking fundamentals, operating fundamentals, they are very critical. And not to mention, it's important on looking from a security aspect also, hardening of servers, what it takes to harden a server or harden a particular application. And they should have spent at least, I would say, 4 to 5 years in the industry before they think of moving on to a real DevOps engineer.
Yeah, I agree. I think they should have built some application so that they have some experience seeing that application in some environment. Then they can better relate these concepts.
Exactly. So they know what problem a developer faces when they interact with operations or what operations go through pain when they have to manage a platform or manage an application. So they need to see both sides of the words to give a proper justification to the job.
I agree. I agree. Good. So thanks, Mandeep, for your time, and thanks everyone for listening to us. I hope you enjoyed as much as we enjoy creating it. So every 2 weeks we will be talking about a new topic. We will talking about a new interesting technology that we have discovered, and then we will talk with industry experts on that. So thanks a lot again for listening. Please subscribe to our podcast and give us feedback. Thanks, Mandeep, again.